Hey everyone, how's it going? The cloud is great. So great, in fact, that I think every single one of you should go back, take your cloud and OT DMZs and merge them. I guess people are still here, that's great. All right. So as I said, my name is Mark. Before we get started, I do need to give a quick little thing that my legal team made me say. I'm here talking on behalf of myself, had some conversations with some friends, some independent research. This isn't really anything related to Whirlpool. Even if it sounds like it is, it's not. Second thing we got going on is I got some AI generated images here, as well as some stuff I created myself. You'll be able to tell the difference. I am an absolutely horrific artist. All right. So I had a buddy come to me a few months ago and said, hey Mark, I just changed all of my password requirements globally to 24 character minimums. I said, cool man, how are you still alive? And he went, well, it was a little touch and go there, but we figured it out, kind of. Said, so tell me what's going on, man. He's like, well, we had no problems. We thought there were going to be problems with the AS400s. The AS400s, we just kind of segmented off, put it into its own little network. You have to VPN in. It's got its own LDAP tree. We're good. I said, all right, then what's the problem? The plant. I said, what do you mean? Well, the shift leads are in charge of recording any downtime on the line. So to give some context, they have 55 plants across the world. And these lines can track downtime down to the 10th of a second. And every single 10th of a second, or every grouping of seconds for that downtime has to be recorded for a reason, for their operational excellence program. I said, okay, that makes sense. So he was finding out that about 5 to 6 times an hour, these shift leads need to log into these machines in order to record their downtime, which is a lot when you go from having an 8-character password to a 24-character password. So he was trying to figure out a way to make this reasonable, because the shift leads just weren't logging in, or they were leaving them open. Either way, not a great situation. So we started talking about different options. Well, what about badge logins using PIV and Active Directory? Well, that was out because they had smart cards. Or they didn't have smart cards. They had RFID, which means that there was no point, or there was no ability to authenticate. So then we kind of settled on well, what if they didn't need to authenticate? And we started talking about Chrome OS. Now, if you're not familiar with Chrome OS has a kiosk mode that's actually pretty powerful. So if any of you have seen touchscreens at a hotel chain that remain nameless, you can tap 3 times in the upper left corner, hypothetically. It'll pop up with a code, and that code oftentimes is the address number of the place where you're at. A little different than that. There's no Alt-Tab, there's no Alt-F4, there's no ability to drop down to a terminal. You are locked into whatever web app is described. So we started looking at how we could build out a web application that allowed the end user to create, or the shift lead to create, their downtime report. And so we ended up with these Chrome OS kiosks with a RFID badge reader on it that linked into the back-end timekeeping system. And what we found out was that they could swipe their badge, we could load up what line they were on, it automatically configured it, and they would just click the downtime and they were good to go. It was so successful that within 2 or 3 weeks, he rolled it out to the rest of the lines in the plant, the other 7 lines. And what we found during that point was that there was really no configuration needed. All of the information was either stored in the timekeeping system, or the configuration for the device was brought down from the cloud. And then we started talking, well, what else can we do with the cloud, right? We use CrowdStrike. We have Rapid7. We have these cloud-managed tools. We're already using the cloud in some respects as a governance plane for security in our OT environments. What does this look like when we extend it? So I know you're all familiar with traditional plant architecture, but we wanted to break this down into the problems we were trying to solve. So the first problem that we were trying to solve was siloed operations. And I think everybody's been to a plant or 5 that really likes to do what they like to do. And rightfully so, right? They have a job, and that's to make sure that that plant runs well. They don't necessarily have to be concerned with the other plants, and that's kind of the point of having those siloed. But it's something that we need to think about. The second one is isolated system management. Now, I know MES teams have never really done shadow IT before, but every once in a while you get some of those shadow IT issues. So how do we prevent these isolated systems from being deployed, and how do we help support our MES teams? Because at the end of the day, their job is the same as the operations folks. They are operations folks. Their job is to keep that plant running and to keep the people working and to keep them on the line. And then the last one, and this one I wanted to call out specifically, is poorly managed identities. Whether or not you have an AD tree specific for each plant that's not linked, or you have an overall forest that spans all of your plants. I have yet to see a good way that identities are managed between plants, or even at a company, right? You know, when we start talking about IT versus OT, a lot of these problems are similar, and we can solve a lot of these problems, or at least work towards a lot of these problems in a similar way. So we came up with 3 major outcomes of what we're looking to do. Number one, we wanted to make sure that we could centralize all of our policy enforcement. So when we're talking about Tanium, right, and that configuration management, GPOs, whether or not we're talking about a CrowdStrike configuration specifically for each type of device, we want to be able to manage that centrally and push that down in a standardized way to each individual plant. And that led into the automated configuration. How do we do vulnerability management? How do we do system level management in a way that is standard across each plant so we have an understanding of how these systems are configured? So when we say, hey, plant A may be hit or plant B may be hit, it doesn't matter because we know what that configuration is. We know what that risk profile is. We have that idea of that threat model. And out of that, that drives that risk reduction. And so we look at standardization, right? We have our consistent global security controls. One of the coolest ways my buddy decided to implement standardized identities across the board was he had a Cloud IGA. And this Cloud IGA then wrote down to each individual plant AD structure. One for IT and one for OT, completely separated. They were also completely separate from all the other plants. And we'll kind of go into how this functioned. But because that IGA sat in the cloud and he was able to write down to each plant and each IT and OT environment, there were standardized controls, standardized identity practices for each individual pillar that they were writing down to, but they couldn't communicate. They were isolated. The next thing this gives us is our unified incident response, right? If we're not collecting the data from every plant, centralizing that, and then performing an analysis, we are missing out on a huge potential opportunity for identifying threats across plants. If a threat actor gains access to one plant and then another plant, they may not necessarily immediately drop malware. They may not necessarily immediately ask for a ransom. They may be poking around to see what they can get. The logs may not necessarily show an attack right away. But these little atomic things that might pop up, a failed login here, an attempt to exploit a vulnerability over there, together when taken as a whole, can lead to a much larger story around a threat actor's activity. And lastly, what we can do when we start looking at this and we put these, let's call them shared services into, we'll say a hub, right? We can start looking at spokes off of this hub and start to scale these ideas and these configurations out to each plant in an automated way. And out of that standardization, we drive our resilience. Because at the end of the day, standardization drives resilience and risk reduction. So if we do have these, and if some of you are familiar with the hub and spoke model, we'll be talking about that in a second, but if we do have these spokes coming off of this hub, we have the ability to do something like, hey, I want to cut plant A off completely. Plant B, C, and D, they can still do the same thing. They still have the access to each other. They still have access to our shared services. But they don't have access to the plant that we know has been compromised. And we can contain that impact. And then within the plant that has been attacked, we have the ability to say, okay, great. Our IT and OT only communicate through our shared services. But now that it's been cut off, we can fail closed and allow that communication so recovery efforts can take place. And if we have standardized tooling, whether or not that's backups, next generation antivirus, or whatever buzzword you want to throw in there, our recovery from an incident becomes way quicker. So the hub and spoke model focuses on 3 major pillars. That's centralization, isolation, and optimization, or streamlining, right? And so what we do is we centralize all of the configuration management, we centralize our shared services, and we treat the hub, right, as the TSA. Now, whether or not you have feelings on the TSA notwithstanding, the idea is that that central hub becomes the gateway for everything that you want to do, whether for identity, for security, and for configuration management. When we talk about isolation, right, this hub and spoke model, traditionally a very old networking concept, but it's being used heavily in cloud today. And when we look at the spokes for cloud and for app development, we have our prod, QA, and dev. And the reason it's set up that way is because, again, we want to mimic these environments as much as possible in dev and QA, but we don't want it to affect prod, right? We may introduce something in development that has a major vulnerability, development gets compromised, but we don't want them to be able to get into our production environment. And that's what we talk about when we talk about isolation. Right, and then the last one is streamlining. If we're making a change in one place that gets percolated down into all lower environments, it's just better. Now, that's not to say that each plant doesn't need their own tender love and care, right? I'm not coming out here and saying that, even though the start of this was a little provocative, right? But when we look at the hub and spoke model, it kind of all starts to make sense, right? And so this is what it looks like from a cloud development perspective. We have our production environment and our development environment. They're able to communicate with the internet and potentially with each other, depending on the use case, through our virtual network in the hub. And they share these services: identity, security, monitoring, and configuration management. So my buddy and I started looking at this model because we had been talking a lot about SaaS companies in terms of how we could implement this in his environment. And we said, well, what if we replace production and development with each plant? Now, also, if you can't tell, this is something that I made and definitely not AI generated. So we took a look at how the hub was structured in a traditional way, and we decided to break this out into 3 zones. So we've got our control plane zone, we have our services zone, and we've got the VNet, or what we're calling the plant communication zone, right? And so at the control plane zone, this is where all of the management takes place. This is where your super admins should be logging in. This is where you focus as much of your zero trust security control, if you want to call it that, as possible, right? Only super admins should be logging into this area. And this is where your orchestration's taking place, your DMZ management, and that kind of thing. Now, the services zone is where we start talking about expanding this kind of idea of the DMZ, right? So many people are doing this today. You have a CrowdStrike configuration panel. You're using the services zone. It's just not in your GCP cluster in a traditional way. You use a cloud-based IGA. You're doing identity management in the cloud in a Cloud DMZ type deal. If you're centralizing your monitoring into a central web console, you're using this. So this is where we start building out those shared services, whether or not we want to talk about DNS or we want to talk about the management or governance of our security tooling. That's where that's taking place. The last zone that we have is the plant communication zone. So this is where the plants are able to actually communicate back and forth. If we want to say, hey, I want to cut plant A off the internet, great. We can do that, and we can still maintain operations going through. And then at the plant level, we can do everything from failing closed and allowing that communication between IT and OT to happen, to having manual backups, right? If your plant has the ability to do things with pen and paper, do things with pen and paper. It's not efficient. Your efficiency is going to go down, but you can still produce product. And again, this isn't right for everybody. But if the government can start storing classified information in the cloud, we as OT security practitioners can start thinking about the cloud as, hey, maybe it's not so bad. Because what we can do is we can start driving a lot of these tactical objectives out of our use of the cloud as a governance plane or as a DMZ or whatever you want to call it, right? We get that secure communication between the plants. We have the ability to lock these plants down and isolate them in the event of an incident. We have security controls in place. We have mitigating controls in place that allow us to say, hey, this configuration may not be secure. This configuration probably isn't the best way to go about doing this. You know, when we look at cloud development and app development today and CI/CD pipelines, there's this idea of, and the buzzword is shift left, right? And without going too much into it, it's about bringing these security controls before the code gets deployed. So if we're using infrastructure as code, configuration management as code, again, insert your buzzword there. But we can start shifting left and start shifting some of these security controls so that way these changes that we're making in the plant don't necessarily have the impact or the ability to have those misconfigurations be promulgated through the environment. And then the identity management piece here, I can't really focus on this enough, right? You know, one of my previous lives, I was a red teamer. I was focused on breaking into networks and doing all sorts of fun stuff, as I'm sure some of you in the audience have as well, right? It's a really fun gig. One of the primary ways we were able to move laterally, exploit privilege escalations, things like that, was through exploitation of identity. You get on a system, you find some other identity on there, then you take that identity and you use that to move on, and then you keep pivoting until you're able to escalate privileges. We look at the octopus attackers from 2 years ago. All identity exploitation, literally octopus for Okta, because they were able to intercept some of those MFA pushes. Identity is key, and centrally managing these identities and ensuring that there is a solid standardized configuration, the importance of that cannot be understated. And that's where we start to get to our final real big outcome of this, is that policy enforcement, of being able to say, okay, great, whether or not, again, another buzzword, right? We're doing policy as code, or we're doing something as simple as just saying, hey, I know I've got these CrowdStrike agents running on TCI systems and a couple HMIs, and I need different configurations for both to make sure that the responsiveness of those systems remains the same. We can do that from the cloud and from a centralized place. We don't need to rely on an MES team or put this on them in a way that gives them an undue burden. All right, so we've talked about the cloud, we've talked about how this is implemented, we've talked about how this governance plane would look, or this DMZ would look. But what would this look like at the plant level? And so I've got another really great piece of what I would call reference architecture here for you. So it's not built on the Purdue model, right? Like look at the OT environment and insert your own level 1, 2, and 3 in there, however you want to do it. But the idea here is that not only are your IT and OT environments completely separated, your SRA can live in your local DMZ, or it can live in the Cloud DMZ, right? That crosstalk and the way that that communication happens is what's important. Being able to model the threat for, hey, I've got an IT system that got taken over because somebody put a USB drive into that system. How do I prevent that from promulgating into the OT network? And that's really what we need to think about when we're thinking about the OT at the plant level. So out of this is where we start to get that strict separation, right? IT and OT can't communicate with each other except through the Cloud DMZ. In the event that it gets isolated, we fail over and we allow that communication in order to get those plant operations up and running. If and when we need to reconnect it to the internet, we don't necessarily have to reconnect it to the shared services. Or we can limit it to a specific shared service, say our backup solution in the cloud, if that's where it lives. And we can start to, after we rebuild, right? Let's say that we're not paying the ransom and we decide to go down the rebuild route. We can pull down all of those policies because they're already stored. It's just like wiping out your dev environment, rebuilding it, and bringing it back online. Now, is it that easy? Absolutely not, right? There is no way that it will ever be that easy. But what we can do is we can start using some of these IT concepts in the OT environment to start making our lives a little easier. So I guess what I'm saying here, right, is we started off with an IT problem of just passwords. How do we make people's lives a little easier? How do we remove some of that undue burden from people having to log in 5 to 6 times an hour, or I'm going to do some quick math on the fly here, 48 times per shift on an 8-hour shift? And how do we make them just say, hey, you know what? This isn't so bad. And out of that, how do we drive better security? How are we able to streamline our operations? And so the cloud isn't necessarily right for everybody. Like, I fully admit that. If you're making bombs, like, maybe we should double think how we're going to implement this. But for a lot of us, right, we can be flexible. We can work within our own risk posture to build a modern security approach. Because just like we saw with Industry 1, 2, 3, 4, and whatever, again, corporate buzzword we want to call this, things are moving fast. And they're only moving faster. And unless we decide to adapt, we're going to be left behind. One of the craziest things I did, right, and not to turn this into an AI spiel, on the way down here is I literally sat on the flight, and on the in-flight Wi-Fi, used an AI tool, an AI client built for this, and then a back-end AI API, to write a program with a React front end, a whole bunch of back-end code, SAML integrations, and then MCP integrations, which stands for Model Context Protocol. And it's a way that that model can integrate with other models and with other services. And I did it in 40 minutes on airplane Wi-Fi. It's insane. And as we start to look at what cloud was 15 years ago, we're kind of in that same boat with AI. It's kind of new. People aren't super sure about it. But we're 15 years down the road, man. We're behind the ball. And we need to catch up so that way we can fully embrace the IT-OT convergence in order to make the world a better place. Thanks, everyone.